Hi, my name's Evan Nolasco, and I'm just going to demo my senior project. This is a house price predictor, and I will walk you through my code and everything. So as you can see up here, I imported everything that I needed for the project, and I imported my housing data set. And now down here, we can see the first and last 5 rows of this data set and all the variables included in it, like average area income, house age, number of rooms, number of bedrooms, area population, and price. And then we have address over here, but we aren't going to be using that. Um, so yes. And then if we scroll down, and I use the describe function, we see that we have 5,000 entries in our data set, so 5,000 rows. Um, so this is a good amount. And then we also get the average of each of the variables. So right here we have average area income, average house age, average number of rooms, bedrooms, and area population, as well as price. So we can see the average area price is 1.23 million, roughly. Um, and then we have all these others. Uh, so um, now let's scroll down, and I devised this pair plot over here. But really, where I want to focus more is right here at the bottom, this last row. So as we can see, like the reason why is because we are comparing it to the price on the y-axis, and we can see that they all sort of have this like positive um, upward trend in their distribution. Um, and we can see like the one that has the minimum upward trajectory is the average number of bedrooms. So we can assume that that doesn't really affect the price of the house as much as the other four. Um, yeah, as we can see here, but we still sort of see like this upward trajectory. Um, either way, it is the one that stands out the most out of all of them. But we see average area income has an upward trajectory, house age has an upward trajectory, number of rooms and area population all has an upward trajectory. So now that's not really enough. So I created this heat map over here, and again we just want to focus on that last row. We can see that right here the number of bedrooms again has the least amount of correlation with 0.17. So once again, we can infer that it doesn't really um, affect price as much as the other ones. Um, but we can see that average area income, it has a correlation of 0.64. So now, so now we want to create a linear regression with price as a dependent variable and the remaining other variables as independent variables. So I put the variables into their own. So I put all the x variables into an x variable, and then y variable, which is a price, into y variable. And then we're creating train set and a test set. The test set is going to be 33% of our data, and then our train set will be the rest of the 67%. So as we can see here, this is our train set right here. Um, Now, this is roughly 67% of our data. As we can see right here, 3,350 is about 67% of 5,000, or it is 67% of 5,000. And so this is 67%. And as you can see, it's randomly chosen, which is good. So you see entry 130, 408, and then it's the same thing for our Y train set. Um, and as you can see, it matches. So we have entry 1522 there and 1522 there. So this price is the price for these entries for the variables. So now I create the linear regression named model, and we fit the X train and the Y train data, and we find our coefficient and y-intercept. So as we can see here in this table, in these two tables, we have our coefficients or our slope and our y-intercepts for each of our x-train variables. The slopes that we see above represent the amount in dollars that the price of the house will change as the x variable increases by 1 unit. So, what does this mean? For example, if the average area income increases by $1, then the price of the house will increase by roughly $21.59. And then that's the same thing for all the other variables. If the number of rooms in the house increases by 1, then the price of the house increases by 119,000 roughly. And then the y-intercept is just the price when all the variables are 0. So now I created a data frame, and we needed to create a prediction. So we pass our X test data, and based on what we've trained, we will see if the prediction fits. So how do we see that? So as we can see here, I created a plot. And our predicted values are pretty accurate. We can tell because our red dots follow that blue regression line almost perfectly. So you see the under predictions and the over predictions are still in line with the regression line. And we can visually see this. So, for example, like if you look at the x-axis, right, at the actual house prices, that's what the x-axis is. The y-axis is the predicted. But if you see over here, it's 0.5, which is 500,000. If you go up and then you go left, see where it matches up, 0.5. So that's how we know that our prediction is accurate. And then the same thing with 1. If you go up 1 and then you go to the left, it should be 1, which it is. So our actuals and our predictions match. And then you do that for the rest of them and you'll see the same results. So now if we scroll down real quick, what we want to do is be able to manipulate each variable to whatever number we want. This way we can change each variable and have a custom prediction based on our existing data. So to do this, I created a function called custom prediction. And basically, as you can see right here, basically the function takes 5 arguments, and it's all those that we have, income, age, number of rooms, area population, and all that. It takes these 5 variables and puts them into a 1x5 array. Then a data frame is created using that array, and then the created data frame is used to predict house price based on the provided arguments. And then as you can see here, that's where it's being done. And we use model.predict, which is the same thing we used up here, model.predict, which we proved that is extremely accurate from our plot with the red dots and the blue line. So as you can see here, this is an example of me using this function. I put 70,000 for the average household income, 1 year house age, 5 number of rooms, 3 bedrooms, and 72,000 area population, and we got 75,000 roughly for our predicted house price. And over here, it's better if we had some sort of graphical user interface, and that's what I created right here. We have these sliders that allow the user to be able to basically set all the numbers and values for each of the variables. And again, we're using that same function that I explained earlier. It's the same exact function, and we're taking the values of each of the sliders and putting them into the array, into the data frame, and then creating the prediction. When you click predict house, then it spits out the predicted house price. So let's see it in action. So let's say I put an income of say 75,000. Average house age, let's say the house age is 4 years. We have 3 rooms in the house and 2 bedrooms, and then the area population we'll say is about 110,000. If we hit predict house price, there's our prediction, about $1.6 million. And we can go back and change everything there as much as we want. Then it'll spit out a new prediction, and with this, we get 2.9 roughly. So yes, this is my project, and thank you so much for watching.